Shubhodayam, welcome to all. Another day of learning a very sacred Vedic mathematics as part of the 7th batch of certificate course on Sanatan Dharma organized by Veda Samskruti Samiti in association with Visva Yoga Vidyapit. Before we start the session on the of Vedic mathematics, we go ahead with singing our Vande Matram. I request Venkat Narayan Garu to kindly sing Vande Matram for us.
Vande Mataram, Vande Mataram, Sujalam Suphalam, Malaya Jasitalam, Sasya Syamalam Mataram, Vande Mataram. शुभ्रज्योत्स्ना पुलकितयामिनीं फुल्लकुसुमितद्रुमदलशोभिनीं सुहासिनीं सुमधुरभाषिणीं सुखदां वरदां मातरं वन्दे मातरं वन्दे मातरम्.
Vande Matram. Dhanyawad Venkat Narayan Garu. As we celebrate the 150 years of Vande Matram, please keep singing and enjoy the beautiful song. And now I request Ram Sharma Garu to do the Pradhana, please.
1 minute meditation and 3 times Omkaram. Oh. 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 ॐ गणानान्त्वा गणपतिगुं हवामहे कविं कवीनामुपमस्रवस्तमं ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनशृण्वन्नोतिभिः सीदसादनम् ॐ श्रीमहागणाधिपतये नमः। ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती धीनामवित्रियवतु। ॐ श्री महासरस्वत्यै नमः। गुरुरेव गतिर्गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे न गुरो परमं शिस्मिरस्मि गुरोः मतिरस्ति गुरो मां पाहि गुरो। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे। श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करम्। शङ्करं शङ्कराचार्यं केशवं बादरायणम् सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मामृतं गमय ॐ शान्ति शान्ति शान्तिः मातृदेवो भव पितृदेवो भव आचार्य देवो भव अतिथि देवो भव ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरिः ॐ श्री गुरुभ्यो नमः हरिः ॐ
ధన్యవాదాలు రామ్ శర్మ గారు. థ్యాంక్ యూ ఫర్ ది నైస్ ప్రార్థన. Only thing is, when you do meditation for 1 minute, kindly see that it is 1 minute. Okay, don't cut it short. Thank you very much. Now I request Goutham Mukherjee ji to carry on with the webinar, please.
सर्वेभ्यो नमो नमः. Sri Gurubhyo Namo, Sarvebhyo Namo Namaha. I will Yesterday I completed just before this Nikhilam, and there is some homework. Today I will quickly cover, I will complete the division part. I will complete the division part, namely the after Nikhilam we have this Paravarta method. This I will complete, and after that, as per the suggestion of our Colonel, respected Colonel Babu Garu, I will do some revision, sort of exercise, and we shall see that how much all the participants here, or students here, have learned that. What is the confusion still, and so on. How it can be one of their major practice in the basic arithmetic things, applying basic mathematics. Now today I'll start with Paravarta method. We have seen earlier that in the Nikhilam method, what we do, we just see the deficiency from nearest power of 10. Like here it is 100 minus 89 is 11, or 1000 minus 888 is 112, and so on. By Nikhilam, Navata Sharma, 9 minus 8 is 1, and 9 minus 8 is 1, and 10 minus 8 is 2. Like that, 9 minus 7 is 2, 9 minus 8 is 1, and 10 minus 9 is 1. That way we did. So deficiency, the difference from the deficiency from the previous nearest power of 10, it is seen here, means which is above. Now, in the Paravarta Jyoja, it is almost the same. It is Paravarta Jyoja means actually transpose and apply. In Paravarta method, the result of excess of divisor from the nearest power of 10 is worked with, and it is actually the opposite of that. And here it is in we could have written vinculum, but actually it is like this. In case of 89, it was deficiency was 11. In case of 112, it is excess is actually 12. So we write deficiency as -1, -2. It is actually basically the Nikhilam method almost, but we do not call it Nikhilam because nothing to subtract from 9 or subtract from 10. Here only we consider that it is a difference from the nearest power of 10, and the deficiency from nearest power of 10, and in this case deficiency is actually negative, actually excess. So what we do this almost the same thing. So 1, 2, 3, 4. should be divided by 112. How do you do it? As I told earlier, that we have nearest power of 10 of this divisor 112 is 100. So we consider that as if we are dividing by 100. So what will be if we divide 1, 2, 3, 4 by 100? What will happen? 1, 2 will be my 12 will be my quotient and 34 will be my remainder. But in this case, what is happening? It is 12 is excess, that minus 1, minus 2, 12 is excess. So in every 100,000, etc., correspondingly, there will be some, it will be have to be subtracted. Earlier it was added because it was real positive deficiency. Now it is negative deficiency, means it excess. So here we do almost the same thing we do, exactly the same thing in fact. So we do this minus 1, minus 2, when multiplied by 1, it becomes minus 1, minus 2. Actually, it is a vinculum notation almost, but we put a real minus sign, not vinculum. Minus 1, minus 2. So 2 minus 1 is 1. And again, 1, that 1 into minus 1, minus 2 becomes minus, again, minus 1, minus 2, and that we put here. Okay. Now we exhausted all the question part. So we now stop, and then 4 minus 2 is 2, 3 minus 2 minus 2 is 0, and 12 minus 1 is 11. So 11 becomes my quotient and 2 becomes my remainder. Is it correct? It is understood? First, let us understand this. Anyone have?
If anyone has any doubt, please raise your hand and ask your doubt. This is almost a revision being taken. Okay?
Yeah, yes.
Please take advantage of this revision. Yeah.
So all the the participant can switch on their microphone, isn't it? Anytime?
They can, if anyone has a problem, they can put it on
Yes,
box.
yes.
I can unmute, but otherwise everyone can unmute and talk.
Yeah. I'll repeat. Should I repeat? Yes, I repeat. So this 1 into minus 1, minus 2. So minus 1 here and minus 2 here. Okay. And now 2 minus 1 is again 1. And 1 into minus 1, minus 2 is minus 1, minus 2. And then, and finally, we adjusted all the quotient. So 4 minus 2 is 2. 3 minus 2 minus 1 is 0. And 12 minus, 12 minus 1, or 2 minus 1 is 1, and 1 is 1 drop down. I will put another, I'll give another example. 1, 1, 2, 3. So it becomes minus 1, minus 2, minus 3. So you see that it is near it cannot be 2 on 2, something like that. No, for that there is a different procedure. It should be starting with 1, so that it is closer to a power of 10, not that it is very far from power of 10. So 1, 1, 2, 3. So this 1, 2, 3 is extra. So we write minus 1, minus 2, minus 3. So actually deficiency is written here, not the extra. Extra is a negative extra, it's deficiency, negative deficiency. So minus 1, minus 2, minus 3. So 1 into minus 2, minus 1, minus 2, 3, minus 1, minus 2, minus 3. 3 minus 1 is 2. 2 into minus 1, minus 2, minus 3 becomes minus 2, minus 4, minus 6. Now 6 minus 6 is 0. 5 minus 3 minus 4 is minus 2. And 4 minus 2 minus 2 is 0. And 13 minus 1 is equal to this, or 3 minus 1 is 2, and 1 goes here. So 12 becomes my quotient, and 0 minus 1, 0 minus 2, 0 becomes my remainder. Now, what is that means? So again, you have to do one thing. These are all concept-wise. This quotient actually is negative 20. So quotient negative 20 means actually basically what I'm doing, bar 12 into 1, 1, 2, 3. minus this 20. So basically, my dividend always becomes dividend, dividend is written as E. E is equal to divisor into quotient. This is actually noted as into quotient plus R. In this case, R is negative 20. So it is same as, so it is 11 into this 1, 1, 2, 3. Okay. And then we write another 1, 1, 2, 3 was there here. So that 1, 1, 2, 3. So we separate 1, 1, 1, 2, 3. So 1, 1, 2, 3 separated. And this quotient was there. Remainder was there like this. That means it is actually 11 into 1, 1, 2, 3 plus 1, 1, 0, 3. Is it clear? Therefore, actually, my final quotient and final remainder becomes quotient is this and remainder is this. Quotient is 11, remainder is 1, 1, 0, 3. Is it clear? Why you did like that? Should I explain the whole procedure again?
Sir, if that is plus 1, you have to subtract, add to the that previous figure, no, sir. Now it will become minus 20. What we have to do if it is only positive figure?
Positive will leave as it is, because like this here, positive. Positive remainder can have positive remainder is the one. For your question, negative remainder is not allowed. We do not call it negative. Remainder is always taken as positive. So what to do? How to make it positive? We reduce the quotient by 1, and then that negative remainder we subtract from the divisor. So 1 more is contributed like this. Okay.
Okay,
Here I have shown the steps. So should I repeat it again? I just quickly repeat. Here see this 13,456, 13,456 is being divided by 1,123. Now, what I do, I excess from the 1,000, nearest is 1,000. So this is, I write, this part I write in negative format, minus 1, minus 2, minus 3. And then 1 into this minus 1, minus 3, minus 1, minus 2, minus 3. This comes to quotient side, and this becomes in the remainder side. Now 3 minus 1 is 2, and 2 into this minus 1, minus 2, minus 3 becomes minus 1, minus 2, minus 4, minus 6, because everything falls in the quotient part. And we have exhausted with the in the remainder part, minus 2, minus 2 falls in that remainder part, and the quotient part is exhausted. So for no further processing, and just add 6 minus 6 is 0, 5 minus 3 minus 4 is minus 2, and 4 minus 2 is 0, and 13 minus 1 is 12. So 12 is my quotient and minus 20 is my remainder. So in fact, this is, when I simplify it, it becomes 11 quotient and 110 is remainder. I go to more examples. Divide 2, 3, 4, 5, 6 by 1, 2, 3. Okay. So what to do? Similarly, this part, excepting the 1, this part minus 2, minus 3 have to write. 2 into minus 2, minus 3 is minus 4, minus 6. 3 minus 4 is minus 1. And minus 1 into minus 2, minus 3 becomes 2 and 3, 23. But 2 is written in the quotient side and 3 on the remainder side. Now, we have not exhausted with all the quotient parts, so that one more line will be there. But what is that? 4 minus 6 plus 2 is 0. And 0 into this minus 2 once becomes 0, 0. Now we have, and that goes to the totally in the remainder side. And we have exhausted now all the quotient part because these 3 lines. If there are 3 digits in the quotient, there will be 3 lines here. Now 6 plus 0 is 0 and 5 plus 3 is 8 and 4 minus 6 plus 2 is 0. 3 minus 4 is minus 1 and 2 is 2 here. Now this becomes 2 minus 1, 0 becomes my quotient and 86 remainder. But this 2, 1, as you know earlier I have learned that 2, basically this minus 1 in the 10th digit means it will basically vindiculum. So this vindiculum. So 2, this one is actually 90. So therefore, this part becomes simplified to 90, 190 and 80. Is it clear now?
Sir, can you explain this one again? How did you get minus 4, minus 6, 2, 3, and 0, 0?
Yeah. This minus 2, minus 3, I multiply this by 2 and it goes to minus 4, minus 6. Okay. Now this 3 minus 4 is actually minus 1. Three minus 4 is minus 1. This we remain keep mentally. Minus 1 as a minus 2 minus 3 into minus 1 become 2 and 3. Okay, this goes to this side. Now, so this is clear how it minus 6 had come and now 2 has come. So 4 minus 6 plus 2 is 0. So this is equal to actually 0. And when you multiply this thing with 0 becomes 0, 0. And 6 plus 0, now you just add 5 plus 3, 4 minus 6 plus 2, 0, 3 minus 4 is minus 1 and 2. So how to this 2 and minus 1? So it becomes 190, 86. So this basically means if I totally expand this 2 into 100, because you know that in Vedic mathematics, both the place value can be both negative and positive. So it is actually plus minus 1 into 10, minus 1 into 10, plus 0, 0 into 100, 0 into 1. So this is equivalent to 200 and 200 and minus 200 minus 10 plus 0. So 200 minus 10 is nothing but 190. So this is happening actually. Basically, if you want to expand your but actually, in Vedic mathematics, we do not do like that. We say that it is actually vinculum. So two and one vinculum because that econino and that nikilam of the charmadasata, that's same thing. Okay. Is 10 minus 1 is 9. Here is 2 reduced to this one and 10 minus 1 is 9, so become 19. So in any format, just read your practice actually. It basically it is 2 vinculum 1. Any more question? Now we come to another one. 4009 divided by 882. And here it is, I could have written 118. It is Nikilam, as per Nikilam, 9 minus 8 is 1, 9 minus 8 is 1, and 10 minus 2 is 8. But here we again write in the vinculum format. 1 and 2 minus 2, like so 8 is more than 5, so sorry, 18. 8 is more than 5, so 18 has to be written like this. We did similar. So as I told that instead of writing vinculum on the top, we are writing here minus symbol explicitly on the left. So now this 4 into 1, 2 minus 2 becomes 4 plus 8 minus 8. And that we add directly 9 minus 8 is 1. This is 8 and what? Directly we get very quickly. You could have done other is also. I tell you how we could in an earlier Nikhilem method like that, we could have done like this 118. So this instead of this line, it could have been this 118 into 4 means 472. 470. It's all the same. But you have to again, that we wanted to avoid this above 5 as I told earlier. So 4 into this 8. So we do not do. So this 009. When you add this thing, it comes to 481. Same thing, it is same. But it is shown that it can be done using vinculum. Now this thing is clear?
Sir, namaste,
Basically,
sir. Can you
okay,
please
now-
repeat this one, sir? This 4009 divided by 882.
Yeah. Uh,
Sorry, one more doubt. How
Huh.
come like the 8 minus 2, when you say the 882 below the 118 is equal near to base of 1000. Am I right, sir? 882 plus the 118 is 882 is near to the base of 1000. Should we take that way, sir? Are we taking that way?
Yeah. It is near
Yes, sir.
1000.
Yes, sir.
1000. So 1000
yeah.
minus this is 118.
Then 2 is when we are minusing 8 is the minus 2. I'm understood, sir. Then 8 minus 1, that plus 2, how it comes, sir? Plus 2 and 8 minus 1, the 118. That 1 plus 2 and minus 2, sir.
And 9 minus 8 is 1, 9 minus 8 is 1, and 10 minus 2 is 8. That way you subtract from 1000 actually. Nearest 1000, nearest power of 10, we subtract that way. So it is the same thing, it is subtraction, as we learned subtraction, but it is a very quick method actually. In the subtraction, you do a lot of things, and say 1000 minus we childhood we learn that 1000 minus this 0 minus 2 it becomes 10 minus 8, and then put a carry here, you put here, add here 2, 1 becomes 2, and then this 8 this 0 minus I mean 8 becomes 9, and then subtract to 1, and again 8 becomes 9. That so we are always adding. So instead of that, we are directly subtracting from 9. So that is it. So Nikhilam Navatas Sarmatas basically is this earlier we to in the subtraction we used to that carry used to add. So it is the same thing as I subtract from 9 itself. It goes becomes easier. So that is the idea of the Nikhilam Navatas Sarmatas. This was your question, how a 118 came? Basically,
Yes, sir.
minus.
Yes, sir. No, sir. Below that, we say take it the minus 2 and plus 2.
Yes. That
So that
18,
one, sir.
18 I write in vinculum format. 2 minus the 2 and vinculum 2. With that one I can do, basically, this is also the same thing. 8 and in whatever you multiply, 8 and vinculum 8 becomes actually 72. This is nothing but 72.
No. Okay, sir. Understood.
There is no confusion. What did I told that we can avoid multiplying with above 5 digits. We can reduce to everything below 5, so that it becomes very easy and transparent that way. So now another one, divide 2699 by 224. Now you see that
Just
divide.
Goutamji, just a minute. The lady who has asked this question to repeat, hope she has got the clarity.
Yes. Please.
I don't know who has asked the question.
Sir, I myself, sir, Padmaja.
No, whoever I requested, whoever asked, please put on your video also.
Yeah, raise your hand and put your video. And now, is the duck cleared?
Sir, exactly. I wanted to know how that 118 became 1 plus 2 and minus 2.
Now you got it?
Yeah.
Now you understood?
No, sir. Just you tell me once again. I was about to ask.
Now, basically, as I told here, we are doing it separately. Nothing earlier also, we are writing in a separate format. But basically, I wanted to This means actually like this. 1, 2 and minus 2 is nothing but 1, 2 and 2 vinculum. 2
Okay.
vinculum basically is 18.
Yeah,
So
okay, okay.
instead of 18, we write 2 and 2 vinculum. Earlier,
Okay.
the vinculum notation I have learned. So here we are writing in a sparse format, separate, so that actually it means actually 8 vinculum, or it is 472. You write in the 4 plus 8 minus 8 that way. It is only it is written in a separate format. Yeah.
So vinculum
In fact, in here also, in earlier Nicola method also could have written 0, 8 separately you could have written.
Okay.
Sorry, not this one.
This
So
one.
here. Say I could have written 2, 1, 1. I could have written like that. So here also this separate become written in a sparse format, separate. Okay.
Okay.
So there's no harm in that. So here actually you are following that procedure.
So instead of 1, 2 and 2 vinculum, we are writing 1 plus 2 and minus 2.
Exactly.
Okay, sir. Thank you so
Vinculum,
much.
explicitly I am putting this in minus. I
Okay.
cannot write very close. It will look like 12 minus 2.
Okay, sir.
So
Okay.
to avoid
Understood,
that,
sir.
I separately have written.
Yeah.
Achha.
Okay, sir.
Now I come to an example where the divisor is not starting with 1 but starting with 2. What to do? This 2699 have to be divided by this one 224. Okay. So what did we do? I first divide it by, instead of 224, I divide it by 2. And as if I am dividing by 112. Let's see what happens. So when I divide 2699 by 112, then the same Paravarta method, what I do, this 1, 2, I separate as minus 1, minus 2. So minus 1, minus 2 into 2, because this minus 1, minus 2 into 2 becomes minus 2, minus 4. Now 6 minus 2 is 4, and this 4 minus 1 minus 2 becomes minus 4 minus 8. Now, as if I am dividing by, instead of dividing by 224, as if I am dividing by 112, I am seeing the result. Now, this minus 1 minus 4 and this 6 minus 2 is equal to 4. And with this 4, I multiply again this one and become minus 4 minus 8. I just do it, work it out. 9 minus 8 is 1. 9 minus 4 is 1. And this 26 minus 2 or 6 minus 2 is 4. So, had I divided 2699 by 112, 14 would have been my quotient and 11 my remainder. Now what happened? I was supposed to divide by 224. So obviously the quotient will be again halved. So it is 12 and 1. This thing is like this in the background. So 224, basically 224 into 12 plus 11 is equal to my 2699, isn't it? So basically it is 224 is 112 into 2, 112 into 2, and this into 12 plus 11. It is same as this your 112 into 24, isn't it? So 224 into 12 is the same as 112 into 24. So therefore, actually, here the procedure is, the blind step procedure is, if we divide it by 2 to get 112, you have to divide again the quotient. So if 24 is the quotient and 12 becomes my actual quotient. Okay, is it clear? If it is clear, I will go to next, this one. This is slightly challenging, but actually, I need not have discussed this one to. But you can get this to see that what challenges you can get. Yes, you should discuss this one. But first we have to get clear with this. So this is a procedure. Earlier, every time we divided something starting with 1. You see, Parvata method, all these things we did with 1 only. But now there is started with 2. So what we do, we divided it by 2 to get 113. It is 112, and then we worked out and got a quotient and remainder, and then we finally divide the quotient again by 2, because we have divided by 2 earlier. So divide by 2, and then quotient is 12 and remainder is 11. Remainder remains the same in this case, nothing, because it is obviously to be less than that also. Now, this challenge comes when divided by 223, which is an odd number. This was even number, is an odd number. Now, when you divide 223 by 2 becomes 111 and a half. And then 111 and a half, actually, 11, this part, 1 and 1 and a half, minus 1 minus 1 and a half. This when multiplied by 1 becomes minus 1 and minus 1 and a half. 6 minus 1 is 5, and 5 into this one, minus 1 into this is equal to 5. This 6 minus 1 is 5. That 5 into minus 1 is minus 5, and 5 into minus 1.5 becomes minus 7.5. So 9 in minus 7.5, 1.5. 9 minus 5 is 4. 4 minus 1.5 is 2.5. 6 minus 1 is 5. 1. And again, when this 50, this also is odd. When you divide by 15, it becomes 7.5. Now 7.5 is my remainder, quotient, and 2.5, 1.5 is remainder. But what does it mean? Half in this, as I told, half in any digit means 10 times of that half means 5 in the next digit. So this will be added as a 5, but this in the remainder side it is like that. So this 2.5 became actually is 25, because 2.5 in the tens place actually is 25. So if 2 comes in the tens place, it becomes 20. If 3 comes in the tens place, we know this value is 30. So why not 2.5 coming in the tens place becomes 25, isn't it? That is the idea. 25, and 1.5 is there, directly come here. But this half in the quotient means half of what? Half of that original divisor. So half of that is quotient is 7, and remainder is this comes as a remainder, basically, because it is this half in this 223 will be that this will come as a remainder, 1, 1. Quotient will be actually 7, but that half of will act as a remainder, contribute to the remainder, half of that divisor. So it is 111.5. We add up all these things and get 138. It is a little complicated. We see sometimes in the leisure. Now, I think as I suggested by this is homework. Please work them out. I will not go to separate topic today. Let me see. In general, actually, I should have told, it should have been circulated. Anyway, it doesn't matter. So tell me what, in the Nikhilya method, what can be done? What exercises?
Now,
yeah,
please
you please devise one problem, division.
Yes, somebody has raised their hand. Please, Padma Priya Garu, or
you tell me what should be divided by what?
Please unmute and talk.
Namaskaram, Goutham. Are we just focusing on the division, or can we also go back to the multiplication?
Multiplication also. Yes, multiplication and division both.
Could we try the Urdhva Sutra one more time with an example? I'm not sure I fully follow the Vinkulam approach. Maybe we can take the same example you did yesterday, 889 times 898 using the
889.
Urdhva,
Acha, 889 into
898. Yeah. Using the Urdhva Tiryagyam.
Urdu Tiryagyam in this case will be very complicated. So we have to convert it into vinculam. Tell me how to do vinculam of this. Consider
From,
that there is a 0 in the left.
yeah, all from 9. So last from 10.
So,
So
what will be its vinculam notation?
it would be 1, 1, vinculam 1, 1.
1 and vinculam 1 because it is 9 minus 8. Then this also is?
Yeah, that's also 9 minus 8.
And then last one?
10 minus 1 is 1.
10 minus 9, yes. This
10 minus 9 is
1. This 1. What about this?
That's again 1. 9 minus 8 is 1. And 9 minus 9 is 0. And 10 minus 8 is negative 2, vinculum 2.
Now, I do Urdhva Tiryagyam. What is that? I can do it any format. We can start with, should I start with the left to right or right to left?
Let's start from left to right.
Left to right? Yes. 1 into 1 is 1.
Yeah.
Now, 1 into minus 1. Okay.
Minus,
this also
yeah.
is 1 into minus 1.
It's minus 2, vinculum 2.
Vinculum 2. I write in the middle. Now come, what to be, what by what?
No,
Now
bring 3.
we consider block of 3.
3.
So first we consider block of 1, directly 1, and then we considering block of 2. So that block of 2 is 1 into minus 1 and 1 into minus 2. And then next is block of 3. What to be done? 1 into
0.
0, 0.
1 into negative 1.
1 into negative is minus 1.
And then negative 1 times negative 1.
So it is plus 1. So 1 plus 1 again becomes 0.
0.
And I write it below that. This is the, this is 2 by hand. Now I come, what will the block will be? Block of 4.
4.
Block of 4.
Yeah.
So 1 into minus 2.
Minus 2.
You tell me.
Yeah, minus 2 and 1 times minus 1 is minus 1. So that's negative 3.
1 into minus 2.
Yeah, negative 3. Then
is it 1 into
minus 2.
Minus 2. Okay.
And 1 plus 1 times negative 1.
Plus 1 into minus 2, and then I have to call minus 1, this 0. Or how do you are doing from below?
Yeah, I went from below.
1 into minus 2, and then this one, no? 1 into minus negative 3, right? You are right. Negative 3.
Negative 3. Then 1 into negative 2. And
no, 1 into negative 3 already done. And then
negative 1 times negative 2. Right? The second digit.
Oh, no. In the when you are considering, it will be like this. This, and this. So it will be 4. So it will be
okay.
1 into this negative 2. There will be This -1, if we start from the top actually, into 0, then this one will be -1 into -1, and -1 into 1.
Internet.
1 into -2, -1 into 0, -1 into -1, and -1 into 1. Clear?
Yeah. Okay, clear.
So this becomes -2. This becomes 0. This becomes 1, and this becomes -1.
Gotcha.
So becomes -2, isn't it?
Yeah. Okay.
And now again block of 3.
Block of 3.
Towards
That's
right.
-1 times -2,
2.
and
This is
-1 times -1. That's 3. Positive 3.
This is 2 and this is 3. So they write 3 here.
Yeah.
Now block of 2.
Block of 2. -2 times -1 is +2, and the other is 0. So +2.
So this is +2.
And then -2 times -1 is 2. Okay.
Now we see that answer is 2, 1, vinculum 2, 0, vinculum 2, 3, 2, 2. Now only thing remains here is this 3, 2, 2 is fine, no problem in that. So only part is that where there is a vinculum is this one is vinculum.
Yeah.
So what does it mean?
So we apply the all from 9 from 10 again here. So that is 10 minus 2 is 8.
10 minus 2 is
8. And 9 minus 0 is 9.
9.
And 9 minus
9 minus 2 is 7, sorry.
9 minus 2 is 7.
9 minus 2 is 7.
Yeah.
And this becomes 9 minus 0 is 9.
9 minus 0 is 9, and 10 minus 2 is 8.
8.
All right.
Okay.
Okay. Yeah, this makes sense. Thank you.
7, 9, 8. That was the thing?
Yeah, that's the answer.
So any more example?
No, I think this is good. I understand.
Acha, one more example, please. Anybody else? Smaller, you do it little smaller. Please do someone.
Some volunteer, please. So that
Everyone can do it, no?
yeah, the revision should be helpful for you to understand. That's the reason you
So
are
your
supposed to
participation is required.
Yeah. So Suresh Garu, you can lead again.
All right. So this is multiplication again, 122 times 234.
Yeah, multiplication.
Okay. So, and we will use the Urdhva Tiryagyam
Yeah.
Sutram. Okay. So, So now, do we want to turn this into vinculum at the 2, 3, 4?
No, nothing can be vinculum here.
Yeah. So wondering, should we use the Nicolam Navatas Charatam Dasita? Yeah.
No.
No.
Here they are not applicable.
It's okay.
Actually, let me, after this I will introduce negative one. So what do you do?
Actually, should we just start multiplying 2 times 1?
Yeah. Yes.
2 times
Exactly.
1. Yeah, okay. Maybe Tiriac method is the approach to take. 2 times 1 is 2. Then do 2 times 2 times plus 3 times 1. That's 7. 4 plus 3 is 7. Yeah. And then bring the 3 digits. 2 times 2 plus 4 times 1. That's 4 plus 4, 8. And 3 times 2 is 6. 8 plus 4, 6 is 14. 4 and carry 1.
Carry 1, where should I write it?
Between 7 and 4.
Not between 7 and 4, right? Below 7.
Below 7. And that's what I meant. Okay. And then do 3 times 2 plus 2 times 8. That's 6. Oh, no, we just finished that. And then last one is 4 times 2 is 8.
Now this one?
Yeah. 3 times 2 plus 2 times, that's 8 plus 6, 14. Oh, okay. There's one more, 14. Okay. And then below 4.
Below.
1 is below 4. And then the last is 4 times 2 is 8. Okay. So the answer is 8, 4, 5, 2, 8, 5, 4, 8.
Oh, 8.
Okay.
Correct.
Yeah. So we use Tiriac method here.
Tiriac method, yes.
Now, can you, looking at a multiplication like this, can you tell which is the best tool to use? Which here, or
Here,
is
if your practice is very strong, this will be this is very good actually. Very good one. Since childhood, you have not practiced it, no? So here
Yes.
now you just practice it, then you can your own speed can consider. But actually, computer has proved that this method is more time consuming and more energy power consuming. Processes involved are less here.
Yeah.
That is proved already. There is a paper on that. I have read that. And experimentally, they have the design circuit for this. One circuit was for conventional mathematics, conventional multiplication. Another circuit for this Vedic Urdhva multiplication. They found that the circuit which used this Urdhva they evaluated this multiplication earlier. Some delay was less, so that power consumed, processes consumed were less, so power consumed was less in this.
Gotcha.
Only since childhood he didn't write, so didn't learn, so it looked like that. Now what you do? I slightly modify it. Suppose it is instead of 234, it is 239. I'll do 122. Same thing.
Okay. And
sorry. 239. And let's consider 1, 2, 3. So what should I do?
can we use vinculum on 239?
Yeah, exactly.
That would be.
So I write here 239, 1, 2, 3. So
2, 4, and vinculum 1.
239, 1, 2, 3. So here we write 2,
4
4,
and vinculum 1.
4 and vinculum 1. And then 1,
2, 3.
This is to avoid multiplication by 9.
9. Yeah, I understand.
Very
That
big
makes
number.
sense. Yeah.
So what we do? Left to
2
right
times,
again.
yeah, 2 times 1 is 2. And then the cross multiplication, 4 plus 4 is 8. 2 times 2 plus 1 times 4. And then the third, 2 times 3, 6, and 1 times
All of you are
negative.
following, no? What Padma?
Yes, sir.
Yes. 2 into 3, yes.
6 and 1 into 1 is negative 1. So that 6 minus 1 is 5.
And 4 plus 2. 4 into 2.
4 into 2, exactly. So 8 plus 5, isn't it?
13.
Yeah.
13. So 3 I write here.
And one
I
below it.
write.
One below it.
Below it.
Then block of 2 again.
Yeah. 4 3 is 12 minus 2 into 1. Minus 1 into 2. That is 10.
10. 0 I write here.
1 below 3. And minus 1 into 3, minus 3. Vinculum 3.
Vinculum 3, exactly.
Yeah.
So now, what is the shape?
2 9 4 1 7.
2 9 4.
So 2 9 4 0 vinculum 3.
And that becomes 29397.
2 9 3 9 7. Yes.
Vinculum 3. Yes. So that means 293.
97.
97. Nikilam Navatasarmatas. Everybody got it, how it is there? Actually, basically, it is 4 0 3, the whole thing. This is the whole, when 0 is there, 0 is same and vinculum 0 is the same thing. So 4 0 3. So we reduce by 1, ekonuneno, and then 9 minus 9 is 9 minus 0 is 9, and 10 minus 3 is 7. That is the idea. So 29397. Okay. All those we are whatever we are doing now, somebody is checking also through calculator.
Yes.
So that is the thing that because it is new to us, so we do not get that much confidence, which earlier we got our own practice since childhood. That procedure we always want to do. But when you get get so much practice that we get confident on that, we'll never commit mistake, and we never so much confidence we'll have that don't have to match again. We know that is correct. Now, okay, somebody can give more example yourself.
Just a quick variation on this, Dr. Mukherjee. If instead of using vinculum, you just want to do 239 times 123 without vinculum.
Without vinculum, it will be very bad. I can do it. It will be looking very bad.
Sir, in this case, sir, in the same case, 239 into 123, can we take sub base for one number and directly the other number?
Huh?
Can we take sub base for one number and the other number the same one?
Sub base.
Yeah.
Sub base method.
So earlier
Can be done. Can be done. Should I do it?
Yeah. Once we will do that, sir.
Yes. So then you don't have to write that much parts. It will be have to 239 and 1. What should be my sub base? Suitable sub base?
Yeah, we will take 250, sir.
250.
Yeah.
So is equal to
0, 1, 1.
0, 1, 1. Oh, 0. Okay.
This we can take the same. 1, 2, 3.
No. No. You have to be also this.
Then the same will
1.
be.
250 minus 1, 2, 3. So
Yeah,
becomes
okay.
27. No. 127. Here, Nikhilam Navatascharam doesn't apply because
Yeah.
it is, we are not subtracting from all 0, 0, zeros. Only that
Yeah.
this is subtracted from 0, 0 minus 3, 7. But it is 5 minus 2, so becomes actually 4 minus 2, so it's 2. And then this. Okay, this is correct?
And this, yeah, this we can do by Syriac
Now,
method.
what will be my left part?
239 minus 127.
Exactly.
So it will be 112. 112.
1, 1. And you check always, everything is correct. So to check, you can do the cross, this also. This also would, should yield the same thing. Otherwise, you know that you committed a mistake. One of them are then wrong. If they do not produce the same one, because obviously either you do something is n minus a or mn minus whatever it is, and something is n minus b, and we are doing it a b, and again we are subtracting by a this b here or a here. It should yield the same thing, isn't it? So if it is not, then you must check both of them so that there must be some error. So 1, 1, 2 is okay. And now you have to do this one.
Yeah, this Syriac method we can do this multiplication, the small
method.
one. Okay. So it will be minus. Okay, these are all no vinculum. So 1 plus 1 we can directly do. 1 into 1 plus 0 into 2. It will be 1.
Let me see whether it can be done with Goutham, isn't it?
Yeah.
0, 1, 1, and 1, 3, 3. Okay.
133. Okay.
0 is 0.
Yeah.
0, 3, 1, 1.
1 plus 1. Yeah, it's 1.
1.
And 1. And minus 3. Minus 2.
1 and 3. 4. Isn't it?
Yeah, 4. Yes.
Now you can block up this one.
Minus 3 plus 3. 0. And minus 3. 3 vinculum.
Equal to.
Okay.
Tell me. 3.
1397.
So this one to 397 I write like this.
Yes.
397 and 1 becomes my carry, isn't it? Carry.
Yes.
This carry gets added here. Becomes answer becomes
113397.
Is it correct?
Okay, sir.
So here itself we did mixed one. Oh no.
Sir, no, we have to divide.
No.
We
Yes.
have to divide 112 by 4.
Exactly. So 115 becomes 56, no?
Yes, sir.
This becomes divided by 4.
Yes, sir. 28.
28. So actually it is divided by 4 I have to do. So I'm sorry, this is not the
28
28.
And 397. 1 carried.
1 carry 397 becomes actually
Yes.
29.
29 397.
397. Now you please check.
Yes, sir.
It's correct. Result is correct.
Yes, yes.
Yes, sir.
Now, thing is that, so here we applied
Two
sub-base
methods.
technique, Nikhila method, 2 methods.
Yeah, but
And
the
for the-
earlier one is easy.
So, was it interesting?
Yes, sir. Thank you, sir.
So this kind of example you yourself design and do, and then you will have a lot of practice.
Sir, I couldn't follow how it came. I couldn't follow after that one, after 0, 1, 1, 1, 3, 3, sir.
1,
How
3,
it came?
-3, yes.
Yeah, from where it came, sir? That I couldn't follow that. Sir. I
Oh,
couldn't understand that.
this is this 1 to 7.
1 to
Because
7, 1 to 7 minus from where, sir?
so 1 to 7 you got from this 250 minus 1 to 3.
250 minus 1, 2, 3 is 133. Am I right?
1 to 7. Okay.
Okay, sir.
We are considering sub-base. My sub-base is 250. So 250 minus 239 is 11, 0, 1, 1. And 250 minus 123 is 127. 127 have to be multiplied. Here we do cross subtraction. This is okay. Both cases becomes 1, 1, 2. And then when I do this one, instead of keeping it 7, we put in vinculum. Now we by this Uddhav we came to that 140 and vinculum 3, 1397. This becomes carry, and then this becomes carry, and 112 divided by 4 becomes 28.
No, sir. Still I am in doubt. So that's 250 minus 127.
Huh?
You said 133 comes from 250 base from 127. Am I right, sir? You said that way. I couldn't follow this
No.
calculation.
The 250 minus 123 is 127. 127 is written as 13 vinculum 3.
Vinculum 3.
Okay. Very correct. Right. Now I understood. Okay, right. Okay. Thank you, sir.
Okay. So this was example, interesting example. Now please tell more example.
Someone else participate. See, by participating, you are learning more. So today's class is entirely for revision and understanding. So make use of it. Somebody can come just like Padmaja Garu or Suresh Garu. Someone else can come and clear your doubts or solve a problem and learn more.
More example, please.
Sir, I have a doubt, sir.
Yeah.
Actually, in the division part, we are dividing the number which is to be divided into two parts.
Oh yeah.
So how
Suppose
should we decide?
I do suppose you do 2, 3, 1. Okay, 2, 3. Okay.
Yes, sir.
And we are dividing them by, say, how many digits? Tell me by what we should divide?
145.
145.
Yeah. So where to means divide the 2, 3, 1, 2, 3 number.
If it is
means,
by 145, so it is
okay.
closest tens power is what?
100.
100. So you have to put the line in there. First you consider as if I am dividing this thing by 100. So
okay. So 231 after 230. Okay. So
but
if the number is 14, then only after 2 we have to put the line.
yes. But if it is suppose it is 945, now tell me.
Yeah.
If it is divided by 945, so closest is
it should be
now
1000.
Now they have to put here. You have to put here.
Yeah, after 23. Okay,
Yes.
sir. Okay, understood, sir. Okay,
Yes.
sir.
Any more question? Or should I go through quickly the slides also show and then
You have only 15 minutes, sir.
I'm charging to how much charge for that? Yes, please.
You have 15 minutes time, so plan accordingly.
Now, let us go back to my presentation. You can see any particular, you see that this line is 9 actually true trivial. You should just look at it sometimes, no problem. I don't want to discuss again. Single digit, then came to double digit, but with single processing. Single processing, because there is only one in the quotient part. Upon dividing by the nearest power of 10, only one thing remains. So, the obviously single processing it will be.
Yeah,
Sorry, not
okay,
single, only single line. Once always will be single one line only. But when it comes to, as I told, that when it comes to double line, this is also single. Processing is single, but it's double line because there are 2 digits in the quotient side. So there will
Yes,
be,
sir.
this will come. Actually, I didn't discuss that time. There is an invisible zero here. We are actually not adding 11 plus 1 plus 22, but we are adding 11 plus 10 plus 22. This is the way of writing. Somebody may think that, okay, what is happening? It is so unrigorous.
Okay.
It's not rigorous. It is not that. Actually, it is basically this intermediate part. I have sometimes went through the algebra of that. Actually, intermediate part gets some error, but that finally gets rectified in the final step.
Okay.
And the whole thing becomes same. This becomes, the individual zeros are there. Actually, it is 100. Similarly, this is actually 440. When you add these things, you get 3106. So that you have to consider. Here also it is actually it is 220. We are already, when you don't have to write this zero, you write like just like that. Don't write this zero. So here it is. You followed these things, no? When I discussed.
Yeah, yes, sir.
Here, this is multiple processing. Because this here, this 1731 remainder is more than the divisor 789. So again, you have to do. So this is called multiple. And wherever you get this another quotient you get, that quotient must be added to this one, this quotient. So that this actually gives to this one. So these are all there. But as I indicated here that if it is more than the away from the tens power, this doesn't get very fruitful. So any question from this? This was with a lot of vinculum example was there. You have to see currently with vinculum and so on. So, did you try these exercises given here?
Yeah, Padmaja Garu, did you try all this? If not, you can do
Sorry,
it now.
sir. No, today I will definitely do because
No, now
yesterday I
you
was
do
in a
it.
Yeah, I will do. I'm doing, sir. I'm started doing.
You can say, I mean, you can
Yeah,
interact with Gautam ji and do it. So everyone can also listen. You also can revise.
Okay. So since practice is almost quite some practice is done. So what we do for tomorrow's class, I just discuss the background. Is it okay? We completed up to Paravarta method. Now, if there is requirement, we can do revision from time to time. Better you try all these things. Whatever is given, either in this part, division by Nichiren method, or multiplication, or this division by Paravarta method, this one. After that, you come back tomorrow, we can discuss. No problem. But now, today, I set the background of the tomorrow's class, the theoretical, which is not part of basic mathematics, just a general, concept concept discussion. Now, idea is this, like this. So far, we have all the divisions we have discussed, but only that Paravarta, Nikhilam and Paravarta. We have seen the division of a dividend and divisor to yield quotient and remainder only. We stopped at quotient and remainder. We didn't go further. So it is like this, that we are supposed to divide this E dividend by D divisor, and we came to got the result as quotient and remainder. So basically, it is E is equal to D into Q plus R. Or if I divide by D, becomes E divided by D is equal to Q plus R by D, where R is always less than D. If it is not less than D, that means you quotient should have been added to something more. So that that D becomes R becomes less than D. Otherwise, he says that sometimes a child may commit a mistake. We say no, your division was not correct. One more could have been put there, or one or two more, so that actually it becomes less. So R is always less than D. But depending upon the requirements, division may be left at finding Q and R only. That what we did earlier so far. The result may be expressed in whole Q and the fraction R by D also. Or either you left at Q and R, or we consider it that it is in like Q plus R by D. Q plus R by D. So like we did, like what we do, examples are there. And then R by D is also evaluated in decimal format. 50 minus 15 divided by 4. We write 3. Quotient and R remainder. This I can write like this, or I can write 15 by 4 is 3 full, 3 whole, and 3 by 4. Or 15 by 4 I express as 3.75. Now this is called the decimal format. For an expression E by D, where E is greater than D, can always be expressed as a whole part. As a whole part, E is greater than D. Whole part plus a fraction of the form n by d. Now we call it numerator and denominator. Instead of divisor, we are called also d as the denominator. Characteristics of n by d is being discussed in the exercise. Depending upon the d, there can be various characteristics. One is that any rational fraction of the form n by d becomes a terminating decimal. It ends when the denominator d is purely comprising of powers of 2 and 5. Like half is 0.5, 1/4 is 0.25, 3/4 is 0.75, 1 by 8 is 0.125, or 3 by 8 is 0.7. It actually, basically, if it is something n by, say, n by 2 to the power n into 5 to the power m. So the number of digits after decimal will be which is greater of this n and m. Okay. So if 1 by 2 is 0.5, 1 by 20 will be 0.05.
Yes.
So like that. So depending on this maximum of this power. So you have seen that this 1 by is 2 cube. So there are 3. This basically is 1 by 2 to the power 3. 2 cube. So therefore there are three digits here. So similarly for 5, 1 by 5 is 0.2 and 3 by 5 is 0.6, and these all, all these things are like this. 1 by 100. Yeah. The irrational fraction whose denominator D ends with, you remember these digits, 1, 3, 7, and 9. A rational fraction whose denominator ends with rather 1, 3, 7, and 9 becomes purely a recurring decimal. 1 by 3 is 0.33333. 1 by 7 is 0.142857, 142857, like this. 1 by 11 is 0.090909. 8 by 13 is 0.615384. Then repeats like this. We put here like this. Actually, there are not very good ways not there to write this dot. We do like this, isn't it? Instead of writing like this, repeating the thing, we just write like this. Repeating. In Bengali, it's called ponoponic symbol. So this is so we have seen that it's two categories I have discussed. One is that if it is purely comprising a power of 2 and 5, it is a terminating decimal, and if it is a it is ends in 1, 3, 7, and 9. Only these 3 digits, 4 kinds of digits. It will become a purely a recurring decimal. But there will be no fixed part. But there is a third category, a mixed category. A rational fraction other than the previous 2 categories will have a non-recurring part followed by a recurring part. 1 by 6 is 0.16666. 8 by 15, 0.5333. 9 by 14, 0.6 and then 4242857. Okay. 26 by 75, 3, 4 and then 6, 6. 6, 6. 35 by 8. These are all like this. Okay. So how it happens? How it happens? Length of the non-recurring part in this case, or length of the terminating decimal discussed earlier, will be the greater one between maximum power of 2 and maximum power of 5 present in the denominator. Length of the non-recurring part. Length of the non-recurring part is 1 here. Here also it is 1. Here also it is 1, but here it is 4. 4 because why it is 4? Because 35 by 48 is 3 into 16.
No. Yes.
16 is 2 to the power 4.
2 to the power of 4.
2 to the
Okay.
power 4. So therefore, it will be this fixed part will be
4.
4. Length of
digits.
fixed part will be 4. And because of this 3 has the characteristics of having 3 into 3. Its connection is with 9, which is single 9. So therefore, there will be this length of this will be 1 also. But in this case, 39 by 56, both can be analyzed. 39 by 56. 56 is actually 7 into 8. 7 into 8.
8 to the power of 3.
So its fixed part will be 3.
Yes.
Okay. And this 7 actually is a fraction of nearest, smallest 999 is called all lines, called repeat 9, REP 9. So it actually goes to this, it is a factor of 999999. This one. Actually, in fact, 7 is 7 into that this sequence 7 into 2 4 5 7 actually it becomes 9999. It is 7 is not a factor of any less number of 9. It is the smallest number of 9s that is a factor which is a multiple of 7 is a factor of the smallest number of 9s. So therefore, this has the 6 number of 9s. So this has 6 as a this is 6 coming from 7, and this 3 is coming from this 3 length 3 is coming from 2 to the power 3. So this is the idea. Now I go to this. A fraction of the third type can be.
Gautam ji, now it is 5 to 5. If you start
Okay.
everything, it will take more than 8 o'clock.
Yeah. So tomorrow we'll discuss.
Yeah. Thank you.
Whatever, just one line. The fraction of the third type can be easily transformed by multiplying by both numerator and denominator with either a power of 2 or a power of 5 in order to neutralize it. Like 1 by 6 is 5 by 30. So basically it is being shown that how it is fixed part and this declining part is coming, it can be separated. So you just go through this. Yourself please read it and home reading this part. You see that it can be by multiplying with either proper number of 2 or proper number 3, it can be neutralized. By neutralizing, you will get this the mystery behind having a fixed part and recurring part can be resolved by having this thing. Then also there is a procedure to do the opposite way, like decimal form to rational form. Earlier, this was a rational form to decimal form, and the decimal form to rational form. Then here also, but then we discussed there is different method for very interesting method for the recurring decimal part. Okay. Today we end the session with this. Thank you.
Thank you. Sorry for stopping you.
No problem. It is ended actually. Whatever I wanted to.
Yeah, I mean, as Dr. Goutham Mukherjee has said that please go through whatever background that he has given for today.
Yeah. These slides, please go through.
Please go through it. It is a very, very interesting and very easily solving method. So if you go through this, tomorrow you will really enjoy how Vedic mathematics really helps you in solving some of these difficult things. In practical life, you may not do this, but this is more applicable into the computers to solve very big calculations.
Exactly.
So please go through this, whatever has been said today, and practice it. Practice the homeworks given, which were not done. So that will only help you. Thank you very much. And now I request Ram Sharma garu to do the pradhana, please.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्रपुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जनाः सुखिनो भवन्तु स्वस्ति
ధన్యవాదాలు Ram Sharma garu. Thank you for the pradhana. Now I request Venkat Narayan garu to sing national anthem. Please All of you rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद.
Thank you, Venkat Narayan garu. Thank you very much. And I'll stop the recording right now.